Hello everyone. Myself Pratik Lagat, and along with me, I have Pawan Kumar Khot, Swaroop Patil, and Divya Patil as my group members. So, for the home assignment of cloud computing, we have decided to create a blog on a comparative study of cloud, fog, and edge computing in IoT. So, basically, after before starting the given blog, I decided to give some brief information about what IoT is. So basically, IoT stands for Internet of Things, which is an ecosystem of different connected physical objects that can be accessible through the internet. Which is the formal definition. So in simple terms, we can say that IoT means everything that can be connected to internet and can be controlled or monitored using internet from our smart devices or PCs. So the method of managing IoT data that is used the most is cloud computing. Fog and edge computing have also been widely employed to speed up and streamline the data processing and bring the intelligence closer to the Internet of Things devices. That create data and act on it. So this block will contrast these three data technology types side by side. We are going to explain the distinctions between cloud, fog, and edge computing, and we are then looking into their particular advantages and strategy of them. So question arises in everyone's mind that why to use IoT. So till now we have understood that everything that can be connected to internet and can be controlled from internet can be an example of IoT. So thus system can be automated so that sensors upload the data continuously to cloud, and various algorithms we use in a machine learning techniques and can be applied to this data so that we can analyze the data properly and produce efficient outputs. And based on that results, the cloud can perform predefined action in response to the sensor data, and the output is received by us. So talking about IoT ecosystem with cloud computing, so the current norms of IoT data storage is cloud computing. So data is kept across several servers and it is accessible online from any device with this type of computing. So users store information on third-party web servers located in far off data centers rather than saving it to the local devices or servers. So for this type of cloud computing, a user must log in into their cloud services account in order to access the data. We can say end-to-end encryption is used to protect the data in this type of technology, and preventing even service providers from accessing the digital assets from their customers is the big importance of this type of technology. And for the Internet of Things, this entails managing and securely storing a sizable amount of data produced by the IoT ecosystem, and are having instant access it from a variety of devices whenever and wherever needed. So that's all from my side. I will hand over the further presentation to Perfect.
Okay. Then we start with the fog computing. First is what is the fog computing? So fog computing is a computing architecture in which a series of nodes receive data from the IoT device in real time. And fog computing is a decentralized computing infrastructure in which data is compute, storage, and applications are located where the data source and cloud. And then fog computing brings the advantages and power of cloud closer to the data is created and acted upon. Then after the nodes and their uses, fog nodes can process the data far quicker than sending the request to the cloud for centralized processing. When the node reaches the fog layer, it decides whether to analyze the data locally or transmit it to the cloud. Then consequently it is possible to view the data offline, because some of it is also preserved locally. Then cloud computing and fog computing, both of which perform all intelligence and processing the stored data on a remote server, and also is differ greatly from the cloud. Then IoT data layers. First one is the cloud, that is analytic processing and warehousing the data, that means data center. Then after fog computing, that is the local data analytics and processing the storage. This is the second for data layers, that is fog nodes. And then last is the edge. This is the real time processing and visualization and micro storage. This is the edge devices and gateway. After then, how does fog computing process the data? So basically local devices is known as fog nodes, and edge devices are used in fog computing to operate. And then IoT becomes taken in a raw data, and this information is sent to the fog nodes near to the data source, and this information is evaluated locally, filtered, and if is required to transmit it to the cloud for a long term archiving. Okay, that's all from my side. I will hand over the further presentation to Pawan.
Okay, so let's see what is edge computing. Like its name suggested, edge means something at a very end or at very start. That is what we call as edge. So basically, edge computing is nothing but technology which uses networking to keep the data as closer to user as possible, as well as it makes sure to keep the data as closer to accessible as possible. There are several of computer network protocols and standards used in edge computing, such as Ethernet, Bluetooth, Wi-Fi, etc., which are being widely used in IoT nowadays. Then we have added few crucial distinctions between three computing methods, each of which has a significant impact on number of characteristics. So let's see that. Scroll down. Scroll down. Okay, so all these cloud, edge, and fog computing are distributed networks, but the difference could be made on the physical deployment of the network and the networking methods. Network is nothing but the path by which we connect the client with the server. In edge computing, edge networks are used which are kept as closer to client as possible, while in cloud computing, centralized networks are used. For fog computing stores the data which is too large to store on edges. So to store such a large amount of data, fog computing uses a series of networks. As we know, in cloud computing we store or upload our data to cloud, and then we access the same data as per our need, but it requires more cost to move that data from source to cloud servers, then again restore that data to local system, and also it overutilizes the servers for all the transportation of the data. But it's not happens with the edge computing, as it make sure that the user is connected to the right data at the right time to optimize the performance and the security. So as a result, it saves the time as the data is very close to the user as compared to the data at the cloud, or we can say the fog. Shortly, we can say that and enhance the speed could be one of the benefit or importance of edge computing in the field of the networking. One more importance of edge computing could be relief to the bandwidth. Then here in this table we have added the summary of all the key point differences between all the three computing terminologies, which includes the latency, scalability, distance, data analysis, and many more. So you can take reference of this table. So that's all from my side. Thank you.
Yes, the next part is the benefits of edge computing, fog computing, and the clouds. The benefits of edge computing: it is a low latency, means the fog network can process enormous quantity of data with little to no delay. And the local storage of large volumes of data speed up computers and enhance data management. And then cloud computing increase isolated third-party servers from local network, providing customers little to no control over their, their data. In fog computing, users can manage a large amount of data locally and rely on their security features and flexibility storage system. So in this for computing does not require a continuous internet access, and local storage combines internet and offline accesses. Data can be accessible by requesting it from local disk or saved locally. Now, next is edge computing. So next is the benefits of edge computing. So in edge computing, data processing is not slowed down. The data is still available at the edges of the IoT network and can be used the right way. And real-time data analysis work efficiently when rapid data processing is required. Network activity is minimal, means the data is locally processed before being sent to the main store and reduce running cost. Data management moves in a single direction rather than the switching back and forth between the center and local disk, which requires less time and processing power. Next is the benefits of cloud computing. Uh, yes, Planting resource when comparing edge computing, fog computing, and the cloud computing. Cloud computing is the always the most resourceful approach for managing a big number of data. And additional to outstanding computing and storage capacity, modern cloud technology offers end-to-end services to handle IoT data, such as security, cutting-edge data analytics, and visualization services, etc. These examples why creating high load application and website with cloud business intelligence is so common. So scalability clouds offers scaling that is the simpler, quicker, and more affordable than edge and fog and easily to maintain. Cloud-based platform provides tools and services for quick and inexpensive maintenance. Next, so features of IoT. The high scalability. IoT system needs to produce, exchange, and storage a lot of data in order to function properly. Just a few example of cloud platform that allow consumers access to the reliable cloud services that can manage the continually growing volume of IoT are AWS, Microsoft Azure, Google Cloud IoT services, etc. Then enhance safety. IoT services must rely on secure data storage to thwart hacker attempts to again access to the network and geo-writes its. And decentralized storage is one way to safeguard sensitive data. To protect a vast amount of data, centralized cloud solution provides built-in security. Then active IoT. The decentralized data storage system safely some of the key IoT needs include accessibility, safety, mobility, and real-time processing. Scroll down. Then new alternative for deployments. From the IoT markets is the booming, and in the future, most devices are anticipated to the network and smart infrastructure, including machines, vehicles, and buildings, generates enormous amount of data every second. And devices will require more process power as time goes on. And cloud computing offers decentralized storage alternative for quicker and less expensive instance. And developers can employ built-in security data management services and third-party computational power by utilizing IoT platforms. Then the then IoT of data is produced by clever analytics system employ the Internet of Things, and it can assist the business and developers in better understanding their clients. And cloud services provides a safe environment for handling, storing, and analyzing these data. There are now several services. Scroll down. Then they improved the security and device to device communication. So in the improved security, devices will eventually be able to use previously gathered data to identify uh, vulnerabilities even before they manifest, and device to device communication by facilitating rapid data transfer between data center and nearby nodes. The clouds enhance communication between hardware and software, and at the edge where the this data is processed, fog edge and edge computing can be helpful for offline communication and micro operations, lowering operation cost and boosting performance. Thank you.